Welcome back to NK Fantastic. I'm NK, your companion on this journey to explore the universe and its 10,000 whys. My friends, have you ever looked up at the night sky and wondered, why is it so dark? I mean, our universe has billions and billions of stars. Our Milky Way galaxy alone has up to 400 billion stars. And there are trillions of other galaxies. If every point in the sky contains a star, whether near or far, shouldn't the night sky be as dazzlingly bright as the day? And what about this? Why are the planets, the moon, the sun all spherical? Why isn't there a cube-shaped planet, a pyramid-shaped one, or, say, a duck-shaped planet? The universe seems to be obsessed with spheres, and our next-door neighbor, Mars. Why does it have that distinct reddish-brown color? Is it angry with us? Finally, a classic question. How can the sun burn? We all learned in school that fire needs oxygen, but outer space is a vacuum. There's no oxygen. So what is the sun burning? These seem like simple questions, but the answers behind them hide the deepest secrets about the formation, structure, and destiny of our universe. In this special episode of NK Fantastic, we will peel back these 4 great mysteries together. If you're ready for a journey of the mind, don't forget to hit that like button, subscribe, and ring the notification bell so you don't miss any fantastic facts. Let's begin. Mystery number 1. Olbers Paradox. Why is the night sky dark? This question sounds silly. The night sky is dark because it's nighttime, because the sun has set. No. This question is much deeper than that. Let's forget the sun for a moment. Let's focus only on the stars. In the 19th century, a German astronomer named Heinrich Olbers officially raised a paradox that, in truth, many thinkers before him, including Johannes Kepler, had puzzled over. The paradox goes like this. Assumption 1. The universe is infinite in space. Assumption 2. The universe contains an infinite number of stars, distributed relatively evenly. Assumption 3. The universe is static, not moving, and eternal, has existed forever. This was the widely accepted model of the universe at the time before the Big Bang Theory. If these 3 assumptions are true, then when you look up at the sky in any direction, your line of sight will sooner or later hit the surface of a star. You might argue, but NK, the light from distant stars, is fainter. Correct. Light intensity decreases with the square of the distance, the inverse square law. A star 10 times farther away will be 100 times dimmer. But the universe is 3D. As you look farther out, the shell of space you are observing is also much larger. The amount of space at a distance of 10 billion light-years is vastly greater than the amount of space at 1 billion light-years. Imagine you are standing in the middle of an endless forest. Whichever direction you look, you see a tree trunk. The trees nearby look big, bright. The trees far away look small, dim. But because the forest is endless, there isn't a single gap where you don't see a tree trunk. Your entire field of vision would be filled with tree bark. The universe, according to Olbers' assumptions, is just like that endless forest. Each tree trunk is a star. Logically, the entire night sky should be filled with starlight. It should be blindingly bright as the surface of the sun. But what is the reality? It's pitch black. What does this mean? It means that at least one of Olbers' 3 assumptions was wrong. And this is where modern science comes in. We now know that all 3 assumptions aren't quite right, but the 2 main reasons that explain the dark night sky are: Reason 1. The universe has a finite age. It is not eternal. This is the game-changing discovery, the Big Bang Theory. Our universe has not existed forever. It had a starting point, about 13.8 billion years ago. Light travels at a finite speed, about 300,000 kilometers a second. This means we can only see the light from objects whose light has had enough time, a maximum of 13.8 billion years, to reach us. The light from stars and galaxies farther than 13.8 billion light-years away, it's actually more complex due to expansion, but let's simplify, simply hasn't arrived at Earth yet. Therefore, our forest is not endless. It has a visible edge, which is the edge of time. The dark patches you see in the sky are the places from which the light has not yet reached us. Reason 2. The universe is expanding. It is not static. This is the real kicker, and the hardest to visualize. In the 1920s, astronomer Edwin Hubble, yes, the telescope is named after him, observed distant galaxies and discovered something astonishing. Almost all of them are moving away from us, and the farther away they are, the faster they are moving away. The universe is not static. It is expanding. How does this affect light? It relates to the Doppler effect. You've surely heard an ambulance siren. As it races towards you, the siren sounds high-pitched. As it races away from you, the siren sounds low-pitched. Light is also a wave. When a galaxy moves away from us at extremely high speed, the light waves it emits get stretched out. Short, compressed light waves are blue, violet, high energy. Long, stretched light waves are red, low energy. This phenomenon is called redshift. For extremely distant galaxies, they are receding from us at speeds close to the speed of light. Their light is stretched a lot. It gets stretched past the color red, into the infrared spectrum, into the microwave spectrum, into the radio wave spectrum. Our eyes cannot see these types of waves. So, even if light from a super-distant star does hit your eye, it has been so redshifted that it is invisible to us. Its energy has been diluted by the expansion of the universe. Conclusion for mystery. Number 1. The night sky is dark not because of a lack of stars. The dark night sky is the greatest evidence for the Big Bang theory. It is dark because 1. The universe had a birthday, and 2. The universe is expanding every day, stretching the light from distant galaxies right out of our visible range. The next time you look up at the night sky, remember that you aren't just looking at space. You are looking at history, and the darkness you see is the echo of the beginning. Wow! Fantastic, right? Let's take a quick break before we get to the geometry of the universe. Mystery. Number 2. Why are planets and everything spherical? We are so used to this image. The Earth is a sphere. The Moon is a sphere. Jupiter is a sphere. The Sun is also a sphere. Why a sphere? Why isn't there a cube-shaped planet like in Minecraft? Or a flat planet like a CD? The answer lies in a single word: gravity. Gravity is a very democratic and lazy force. Democratic, it pulls on all matter equally. Lazy, it always tries to pull everything into the lowest possible energy state. Imagine a planet just beginning to form. It's a giant, swirling cloud of dust, rock, and gas. Every particle in this cloud is pulling on every other particle due to gravity. Gradually, they will all be pulled toward a common point called the center of mass. This is the key. Gravity pulls everything toward the center. Now, imagine you are trying to sculpt a planet. If you have a mountain of material sticking out, for example, making the planet a cube, the gravity at the center will pull the peak of that mountain inward more strongly than it pulls the valley next to it. Conversely, if there is a valley, a concave edge, the surrounding material will be pulled down to fill that gap. Gravity relentlessly shaves down, flattens, and pulls in. It wants all points on the surface to be as close to the center of mass as possible. And the only 3D shape that satisfies this condition, where every point on the surface is equidistant from the center, is a sphere. It is the state of perfect balance, the laziest, most energy-efficient state that gravity can achieve. This state is called hydrostatic equilibrium. But NK, you ask again, then why does Earth have Mount Everest? Why isn't it perfectly smooth like a billiard ball? Ah, a very good question. This is related to a battle. Gravity, which wants to collapse, versus material strength, which wants to hold its shape. For small objects like asteroids, comets, take a rock. Its own gravity is too weak. It's not strong enough to overcome the chemical bonds, the stiffness of the rock. Therefore, the rock can keep its weird, potato-like shape. That's why asteroids are often lumpy and irregular. They are not too massive enough for their own gravity to sculpt them into a sphere. For large objects, like planets, when an object accumulates enough mass, around a few hundred kilometers in diameter depending on the material, its gravity becomes overwhelming. At this point, gravity, material strength, even the hardest rock gets squashed and molded like clay. Mount Everest, while 8.8 kilometers high, is nothing compared to Earth's 12,700 kilometers diameter. It's just a microscopic speck of dust on a billiard ball. If you shrank the Earth down to the size of a billiard ball, you wouldn't even be able to feel Mount Everest with your finger. Gravity has flattened everything to near perfection. One puffy secret. Actually, Earth and other planets are not perfect spheres. Why? Because they also rotate. As the Earth spins, it creates a centrifugal force, like when you spin a bucket of water and the water doesn't fall out. This force is strongest at the equator, causing the material at the equator to bulge outwards. The result? The Earth is slightly squashed at the poles and bulges at the equator. This shape is called an oblate spheroid. Jupiter and Saturn, which spin extremely fast, bulge and flatten even more noticeably. Conclusion for mystery. 2. Planets are spherical because it is the default and laziest design of gravity. Gravity is the master sculptor of the universe, and it only likes to sculpt one shape, the sphere, the most balanced and energy-efficient shape of all. See? Even the universe prefers simplicity and efficiency. Next up, let's talk about color. Why is our neighbor so fiery and red? Mystery, Number 3. Why is Mars red? When we look up at the sky, Mars stands out as a reddish-orange dot. It's no surprise the ancient Romans named it after their god of war, Mars. It has the color of blood and fire. But why is it red? The short answer, if you had to guess, you'd probably guess right. Rust. That's right. The entire planet of Mars is rusty. The scientific answer is that the surface of Mars is covered in a massive amount of iron oxide, specifically iron 3 oxide. This is the exact chemical compound that creates the red color of rust and also our blood in hemoglobin. The more interesting question is, why does Mars have so much rust? To get rust, you need two things: iron, Fe, and oxygen, O. 1. Where did the iron come from? This is the easy part. Just like Earth, Mars was formed from the same primordial cloud of dust and gas in the solar system. This cloud contained lots of heavy elements, including iron. As the planet formed, the heavy iron should have sunk to the planet's core. This happened on Earth. Our core is mostly iron and nickel. But it seems that Mars, perhaps due to its smaller size and weaker gravity, kept a significant amount of iron on its surface and in its crust. Then, over billions of years, massive volcanic eruptions, like from Olympus Mons, the largest volcano in the solar system, spewed this iron-rich dust all over the surface. 2. Where did the oxygen come from? This is the tragic part. Today, the atmosphere of Mars is super thin, only 1% of Earth's, and is there is almost no free oxygen. So, where did the oxygen come from to rust all that iron? The answer takes us back in time about 4 billion years ago. Back then, Mars was a very different place. Scientists have near-certain proof that Mars once had a thick atmosphere and liquid water flowing on its surface. We see dried-up riverbeds, deltas, and minerals, like clays, that only form in the presence of water. And when you have water, you have oxygen, the O in. So, what happened? Scientists believe a catastrophe occurred on Mars. It lost its protective magnetic field. Without a magnetic field, the solar wind, a stream of high-energy particles from the Sun, blew in and stripped away Mars's thick atmosphere. As the atmosphere thinned, the liquid water began to evaporate and break apart. This is the key process. Powerful ultraviolet, UV, radiation from the Sun shone down, no more ozone layer to protect it, splitting the water molecules into hydrogen and oxygen, O. This process is called photodissociation. Hydrogen, being very light, escaped into space and was lost forever. Oxygen, being heavier, was left behind. But free oxygen is an extremely reactive element. It was desperate to combine with something. And what did it find? A surface, covered in iron. Boom! A planet-wide oxidation, rusting process took place over billions of years. All the oxygen that was once in the water became permanently locked into the soil and rocks on the surface, forming iron oxide. And there's one more factor: dust storms. Mars is famous for the largest dust storms in the solar system. These storms can cover the entire planet for weeks. Strong winds have blown this rust dust, called regolith, high up, suspending it in the thin atmosphere. This is why it's not just the ground on Mars that is red, but even the sky on Mars is a pinkish-orange color, instead of blue like Earth's. We are looking through an atmosphere full of rust. Conclusion for mystery. Number 3. Mars is red because it is a dead planet. Its red color is the grave of iron buried by oxygen, the very oxygen that was ripped from the water that once gave the planet life. The red color of Mars isn't the color of war, it's the color of an ancient cosmic tragedy. Profound, isn't it? And finally, let's get to our final boss, the source of life for our entire solar system. Mystery number 4. How does the Sun burn in a vacuum? This is a question I bet 9 out of 10 of us wondered about as kids. We learned the basic fire triangle. You need 3 things. 1. Fuel, e.g. wood. 2. Heat, e.g. a match. 3. An oxidizer, e.g. oxygen gas. You take away the oxygen, the fire goes out. But outer space is a vacuum. It has almost no matter and certainly no oxygen. So, how can the Sun, a gigantic ball of fire, burn so brightly for 4.6 billion years right in the middle of that vacuum? The answer, and this is a major plot twist: the Sun isn't burning at all. The word burning, combustion, that we use every day refers to a chemical reaction. This is when atoms rearrange their bonds, for example, and release energy, heat and light. What happens inside the Sun is not a chemical reaction, it is a nuclear reaction. These are 2 completely different concepts on a completely different energy level. If the Sun were burning hydrogen with oxygen in a chemical way, it would burn out in just a few thousand years. But the Sun doesn't burn its fuel. It fuses its fuel. We call this process nuclear fusion. Let's dive into the Sun's core. This place is unimaginable. Temperature, 15 million degrees Celsius. Pressure, over 250 billion times Earth's atmospheric pressure. In these extreme conditions, matter doesn't exist as a solid, liquid, or gas. It's in the 4th state, plasma. Electrons are stripped from their atoms, leaving only bare nuclei. The Sun's main fuel is hydrogen, H, the simplest element, just 1 proton. Normally, protons, which have a positive charge, would repel each other, but in the pressure cooker of the Sun's core, Its immense gravity squeezes these protons so close together that the strong nuclear force, a fundamental force of the universe, grabs them and glues them together. This process, called the proton-proton chain, happens like this. 1. Step 1. Two protons, hydrogen, collide and fuse. One proton turns into a neutron via the weak nuclear force. They create deuterium, heavy hydrogen. 2. Step 2. This deuterium particle collides and fuses with another proton. They create helium-3. 3. Step 3. Two helium-3 particles, created earlier, collide and fuse. They create one stable helium-4 particle and release two of the original protons to continue the cycle. This is the key. 4 hydrogen particles, protons, 1 helium-4 particle. But if you weigh them, you'll find something strange. The mass of one helium-4 particle is slightly lighter than the total mass of the 4 original hydrogen particles. A tiny bit of mass has disappeared. Where did it go? It was converted 100% into pure energy. This is where the most famous equation in the world comes in, by Albert Einstein. Energy equals mass times the speed of light squared. Because the speed of light squared is a gigantic number, even a tiny amount of lost mass creates an astronomical amount of energy. The scale of this: every second the sun fuses, not burns, about 600 million tons of hydrogen into 596 million tons of helium. Those 4 million tons of missing matter every second is the light and heat that the sun radiates. That is the energy that sustains life on Earth. So, what role does the vacuum play? The vacuum isn't a problem for the sun. On the contrary, it is the ideal condition. A vacuum is the most perfect insulator. Because the surrounding space is a vacuum, the sun doesn't lose heat through conduction or convection, like you lose heat standing in a cold wind. It only loses energy in one way: radiation, by emitting light. This perfect insulation helps the sun maintain the 15 million degree temperature in its core to keep the nuclear fusion reaction going. Conclusion for Mystery Astrophysics: the sun does not burn. It is a gigantic, self-sustaining nuclear fusion reactor. It doesn't need oxygen. It only needs its own gravity to squeeze its hydrogen fuel, turning mass into energy. The sun is essentially a giant hydrogen bomb, but instead of exploding boom all at once, its enormous gravity keeps it exploding in a controlled, continuous way for billions and billions of years. Conclusion. Outro. And just like that, we've traveled through 4 of the universe's big questions. We learned that the night sky is dark because the universe is expanding and had a beginning, the Big Bang. We learned that planets are spherical because gravity is a lazy sculptor, always seeking a state of perfect balance. We learned that Mars is red because it is a rusted planet on a massive scale, a tragic monument to a world that once had water. And we learned that the sun isn't burning at all, but is a magnificent fusion reactor, turning matter into energy via. The universe is truly amazing, isn't it? The simplest seeming questions often lead us to the grandest answers. Thank you for joining NK Fantastic on this episode. Which mystery impressed you the most? Or do you have other why questions you'd like us to explore? Let me know in the comments below. Don't forget to like and share this video if you found it fantastic, and subscribe if you haven't already. I'm NK. See you next time for more fantastic facts.